Hello folks, welcome to another episode of I Want to Know, the show dedicated to North Brantford government, how it operates, and businesses and the people involved in the businesses and government. Today I'm fortunate enough to be joined by Emily Yale, who has a startup company. Is it a robotics company, would you say? Or?
Yes. Okay,
robotics company called Land Maverick, and it's a very fascinating story. So Emily, welcome to the show.
Thank you for having me.
Of course. Why don't you tell me a little bit about you, your history, where you went to school, and then we can get into what inspired you to get into this.
Sure. So currently I'm a double major on the master's level at Fairfield University and the University of Connecticut. That was an accident after doing an undergrad degree in mechanical engineering at Fairfield and an individualized degree in business. Through having to do two majors, I needed a capstone project that would fulfill both of those senior projects. And I really wanted to build more robots. I built robots competitively in high school. I built off-road vehicles competitively in undergrad. So we wanted to build an off-road vehicle. And we started looking for a market that needed a robot like this. And we looked at small farmers, we looked at golf courses, and really settled into golf courses as our first target market because of their very enthusiastic response to this. We're big believers in Bob Dorff customer discovery, and when someone says, I want it, we follow it.
Were you into manufacturing off-road vehicles first, or were you into robotics first, or were they in conjunction with each other?
I started with robotics first.
Really?
In high school, I joined Guilford High School's robotics team. It's a first FRC team. So we'd have 6 weeks to build a robot, then we'd put it in a giant plastic bag, couldn't touch it, and then we'd go compete around the country with it. So used to very fast-paced development cycles, very challenging, very high-stress environment. And that's what I did. That was my robotics background. And then when I got to undergrad, I took on starting an off-road vehicle building team, which we would get a crate with a Briggs & Stratton engine in it, and then we had to build the entire off-road vehicle around it, stick a person in it, and then get it durable enough so we could jump it off Jersey barriers.
With a person in it?
Yes.
Now, how did you come? Who was the lucky soul to be the one to bounce off a Jersey barrier in a custom-made?
I've done it a couple times.
Really? You survived?
Yeah.
Success.
The 6-point racing harness really helps with that process.
Okay, one would hope. Yes.
Yes.
Airbags involved?
There were no airbags.
Wow. Okay.
But.
Did you guys machine all the components yourselves, or were they off-the-shelf components?
We would do a combination of machining things ourselves, sending things out to fabricators in Connecticut, and then off-the-shelf components.
Okay. Wow, that's amazing. Okay, so right now you're still in school.
I am on my last semester of grad school.
Wow, good for you. And so tell us a little bit about this. Does this guy have a name?
This is Mav.
Mav, okay.
This is Mav.
And this is one of 6?
Yes.
You have currently having your stable?
Yes, this is one of 6. This is our third version of our robotic unit. Version 1 was 2x4s. Version 2 went together with 400 rivets, and we learned a lot during that process. So this one went together with a lot less work.
Well, you've learned over time,
yes.
Like from version 1, Mav 1.
Yes.
Tell us a little bit about the process of developing Mav 1. I mean, you start out with sketches and drawings.
Yes.
Using SolidWorks, I presume, or something like that.
Yes.
What was the process from concept to actual manufacturing of bits and pieces?
So we started with, what does the robot functionally need to do?
Okay.
It needs to have tires. It needs to have suspension. It needs to be able to move. It needs to have a ground clearance. So when we start combining all of that together, and then we're like, all right, well, let's think about, what material does it make sense to use? How is it going to go together? Are we making, just a mock-up to figure out, is this the right size, a low fidelity 2x4 kind of prototype, or are we building, the version that this is, which is we're going to push everything to ISO 9000 facilities. We're only going to do the final assembly ourselves kind of deal. So it's a lot of, thinking through it, and it's a lot of along the way, a lot of creativity.
You knew all along that you wanted to use this for what you're using this for?
Yes.
Or was it just you wanted a mini truck to do something?
So we figured out pretty early on that we wanted to do soil sampling.
Okay.
Because we saw that as a gap in the market. So on golf courses, what they do right now is they take a hand probe and they'll go take 5 to 10 data points per hole. Now that hole might be 4,000 or 400, 500, 600 feet long. And those 5 to 10 data points are tiny compared to that. So what this can do is this can go out and can take 200 to 300 data points in the same space. So by doing 20x the amount of data, we can then deeply impact their ability to apply chemicals. And that's when we're like, oh, this is really an issue, because the robot can take 20 times as much data as the human can. So then we can really change the granularity of the data, so that then we can change how the courses are applying chemicals.
So you can see the gap in the market where, like, golf courses, all they care is that they want the grass green.
Yes.
But there's consequences to that.
Correct.
First of all, what you're saying before to me is that, in order to get green grass, they just pour a bunch of fertilizer down.
Yes.
And they get green grass.
Yes.
But there's consequences to that. First of all, it's expensive when they don't necessarily have to spend that money to get green grass. And, there's consequences to our environment. Nitrogen, they need nitrogen for green grass, but then, you end up contaminating the water tables and a bunch of other collateral consequences. So you're able to see that.
Yes.
And then say, okay, well, we can develop a much more efficient way of analyzing the soil. These guys can save money on fertilizing, or at least pinpoint much more accurately where and what to use for fertilizer, where to use it more, what's fine, and hopefully the long-term result is that they don't spend as much money and we don't have green oceans.
Correct.
Right? Like with a bunch of growth from too much nitrogen. Is that kind of right?
Yeah, so we went through a very scientific process to figure out what market we wanted to be in with this type of technology. And then we found the market, and then we have tailored the technology to the market. And that's what a lot of entrepreneurs don't spend enough time on, is figuring out what market they need to be in. They're like, oh, I've got this great idea, and my 2 best friends think it's cool, so we should do that. Versus, if you really are scientific about what market you want to go into, you're doing a lot of customer research and a lot of customer development before you jump into the prototype level, before you're going to build a very expensive unit. And that's, I think, what discourages a lot of people from going into entrepreneurship, is they don't prep the idea enough and they don't acid test their idea enough before they start building really expensive prototypes. That's why the first one was made out of 2x4s, because it was cheap, because we could be like, okay, this is the concept, and then we could go from there once there was a lot of golf courses saying, we want it.
So we're interested in your product, so then let's design MAV2.
Yes.
And with MAV1, you're able to, first of all, work on the programming, work on the structure of the vehicle, make sure it's nimble enough to do what you need it to do. And it's run like autonomous, correct?
Yes.
So you developed the structure in the batteries.
Yep.
How long was the original battery life?
So we've always had flexible battery life because we...
So you can plug in one battery for one application and then plug in a different battery for a different application?
Yes.
That's pretty cool. Yeah, okay.
I'm really into making things modular. I grew up watching Alton Brown's cooking shows, and he always said there's only one unitasker in the kitchen, and that's the fire extinguisher. So it's, how can I get multiple uses? How can I get a thing to do more than one thing? How can I make something modular? So our robot is currently set up to do 2 nutrients, to sample 2 nutrients. It's eventually going to have 10. Mm-hmm. It might have 15, but it's the same frame that can do all of that different work.
Very modular.
Yes, That's the goal.
So then, what challenges did you kind of solve over time from MAV 1 versus 2, 3, and 4, and 5 and 6? Like what has been the evolution?
So there's been a lot of different choices with manufacturing. There's been a lot of different choices with individual components. We've really been relentless in driving down our manufacturing complexity, driving down our assembly time, driving down our complexity. So on this particular unit, we switched from a CNC'd component that cost us $175 a piece to a sheet metal piece. It takes 3 pieces of sheet metal and 8 screws now, but now the BOM cost is $36.
Wow.
So that's the kind of thing we're looking for, is how can we drive down costs relentlessly? How can we improve the manufacturing? And that's a lot of what we've been working on.
So currently you're trying to make this as nimble as possible. This is so cool. I just want to ride it around the parking lot, but that would be bad. So you're working on, continuing on making it more nimble, light, transportable. What is the current battery, the standard configuration? How long does the battery last?
The standard battery configuration is 8 hours of runtime.
And you let this run, do you like GPS
Yes.
map a golf course and you just let this do its thing and
Yep.
you see it comes back to port?
So we'll take the map of the golf course, we'll put a virtual electric fence around every place that the robot is allowed to go. We'll mark off the areas it's not allowed to go. It then is able to compute the best way to get around the course. We stick it on the course in its charging station, and then when it's set to go, it just leaves its charging station, go and does its soil testing, and then comes back and kicks all the data up to the cloud, and it's available on a smartphone.
Oh my heavens. Do your customers say, I really want to know nitrogen content versus I really want to know some other content of the soil? And are you able to change the probes or the measurement devices to suit the customer's needs?
So because we've focused on the golf course industry right now, we already know what they're looking for. So the majority of their daily decisions are based purely on moisture and temperature. Mm-hmm. Then after we've got those settled, then we can go look at the rest of the macronutrients and the important micronutrients. So it's been well established in golf what are the 10 most important nutrients and what are the 5 most important nutrients and what are the 2 most important nutrients. So we didn't have to go do that research and reinvent the wheel. We could take this well-established
industry standard, I guess, desires, right?
Yes, the industry standard scientific desires and build a robot around that. And really what we're doing is we're taking a labor-intensive human process of going and collecting the soil samples manually and just replacing it with a robot.
Wow.
And that's my view of automation, is that humans shouldn't do boring, repetitive tasks. Those are good for robots. Right. Humans should do the complex tasks, such as looking at the soil levels and then deciding how much water and chemical to put on.
Yes. The more, active thinking type of stuff.
Yes.
And then, so you would think that also towns, town greens, Brantford, Guilford,
yep.
North Brantford eventually, right? They would be interested in the same sort of information because really the goal is just healthy green grass.
The goal is healthy green grass, and we're also expecting that this is going to become very interesting to sports fields along the way, as there's the big push to remove all sorts of fertilizer, but still keep the grass in high quality, because a large portion of injuries in sports right now is actually head to grass, not head to other human, or head to ground, because there is no grass. And then the soil compaction goes up, and the soil actually becomes quite dense, and you can get a concussion just from impacting the soil. So we're expecting that along the way, sports fields are going to become interested in this because it's going to be another tool to help them maintain that grass better, particularly as they can effectively remove the weeds to keep the grass more abundant, which is going to reduce the chances of having a head to soil injury.
Mm-hmm. So then you can help and analyze the soil condition to reduce or make sure that it falls within a certain density?
Yes.
Wow, that's amazing.
Well, also, when the grass dies, the soil density increases.
Okay, it gets harder.
Yes, because the grass provides some cushion. The grass also keeps the soil at a certain density because of the roots actually being in the soil.
Okay. So eventually, you know, you're talking about one sort of customer base at this point.
Yes.
Moving forward, you can see so many uses for a tool like this. You know, we have contaminated areas that, you know, a developer or a town or, you know, the government may want to say, look, we don't want people going into this. Let's just use this, Emily Yale's MAV 5 or 6, and go in and analyze the soil for different contaminants. What are the capabilities do you foresee there?
So as we're looking at the different market verticals that we could go into, we have to analyze what that different market vertical needs. And some of them are going to need much more specialized soil probes on the robot to take much more specialized samples, as well as they might also need different frame components to be able to get that done more effectively. So when we...
Or you can mount lasers to this thing. I mean, because laser analysis, right?
Laser analysis is totally possible. But what we did a lot in the beginning that I don't think a lot of startup companies do is we actually went through 27 different market verticals that we could go into and analyzed all of them, and then picked golf courses as the one we were going to go with. I mean, we had everything under the sun that this robot could do in terms of soil sampling and ground mapping. And we said, this being golf courses is the one that we're going to do. And we spent a lot of time making that decision. And that's another thing that I don't think a lot of entrepreneurs think about, is they don't think about, you know, is this really the right target market? I see a lot of entrepreneurs go try to target college students. College students are great. They don't have a lot of buying power. So they're not always the best target market. And I think that there'd be more success in entrepreneurship if people really dug into, you know, what's my core target market? Is this a good target market? And then made decisions from there.
When you were, to digress a minute, I'm so fascinated by this, so as we're talking, I'm just coming up with, you know, new questions. But as you were developing this, and this was in the concept stage, you had a couple of different major components to this.
Yes.
Right? You had a hardware component. You had to figure out, you know, what can we afford to do, keep it light, keep it strong, make it universal to some degree. And then you had like a programming aspect to this as well. You know, what kind of software you're going to use, and how are we going to integrate everything. And the motors, you have four-wheel drive, four-wheel steering, and all these components have got to talk to each other. Was this just a part of your core education, or how did you really kind of hone in, or find people to advise you on how to hone in on marrying all these components?
It's a lot to learn. So the hardware mechanical components, that comes naturally to me. That's my background. The electrical is a little more difficult. There's a lot of learning and a lot of research that has to go into that to make those decisions. The software, I brought in a partner to work with. And we have a really great relationship because we start with everything on the flowchart level. So we both have a very deep understanding of the high level. And then Larry goes in and digs through all of the nitty-gritty details to get in between the high-level functions.
So high-level function would be like, okay, I need this to do, I need A to do a function.
I need the drive CPU to tell all four motors to go forward until it reaches GPS coordinate this, and then I need all the drive motors to stop. So Larry and I communicate at that level, and then he goes in and actually writes the code that makes that happen.
So Larry is a part-time partner of yours.
Yes.
Is that correct? And he has, is he an electrical engineer, or?
He has a degree in computer science. Computer
science. Okay. From UConn as well, or?
University of New Haven.
UNH. Okay. Right, it's cool. And then, so what other actors or advisors did you get involved with this along the way, other than your education staff, I guess?
So they're
Who did you tap?
So we tap both industry professionals and academic advisors as well. So one of our engineering mentors, whose name is Kevin Waugh, he has 20 years of experience in product lifecycle management. So he's really helped push the product out of the infancy prototype stage and into the more advanced, everything's getting done at an ISO 9000 facility. And really relentlessly driving us on, reducing mass, because that reduces battery life, that increases runtime, that reduces motor components. And really holistically looking at the whole engineering process to understand what is going to get us the most bang for our buck in terms of design time. So that's part of why this whole robot only has 4 custom components on it.
Mm-hmm. Everything else is off the shelf.
Yes.
It's kind of like a golf cart, right? I mean,
it actually sits on golf cart tires right now.
There you go.
And sitting on golf cart tires, while it's effective in terms of the BOM cost and they're easy to work with, it also reduces the golf course's anxiety about having this on their course and increases our % chance of customer adoption. So with the robot setup right now, it actually only puts 3 PSI of pressure on the course, which is right in spec with all of their other equipment.
Well, compared to, they have actual golf carts driving up and down
Yes.
a lot of these, and that's a lot more, much more.
Yes, those are several hundred pounds more than this robot.
Right, sure. So it's a very low tread path, I guess you could say.
It's a low pressure path.
Okay, right. Okay, so tell me a little bit more then. So we bounced around a little bit.
Yes.
So go ahead, just shoot.
So this robot, as you see right here, is pretty close to being our most perfect robot yet. We've really been able to drive down a lot of the BOM costs with some smart engineering, and we've also been able to work with some really great fabrication shops.
Right, I was just going to ask you about that, done here in North Branford, right?
So Canton Racing Products has done all of the welding on this unit.
Aluminum welding.
Yes, they did all the aluminum welding. They're fantastic at it.
They welded the off-the-shelf components, or they fabricated the suspension arms and stuff like that?
They fabricated the suspension arms and the cage. We gave them lots and lots of raw chunks of metal,
okay.
And then I come back a couple weeks later and pick up these finished cages.
Right.
They do a fantastic job of that. And they're always willing to chime in with how to make the design more effective. We're actually working with them for our next iteration of the design that reduces welding by 40%.
Wow, all right, great.
And that's a big deal to reduce welding by 40%.
And you're based in Branford, correct? But a lot of the components are in North Branford.
So the robots currently inhabit a 3-car garage in North Branford.
Okay. And do you hope to expand in North Branford and develop your own facilities in North Branford? We
would like our own facility in North Branford. It's a really strategic location. It's close to 95, it's close to 91. I can, when COVID's not an issue, right. I can be in
sooner rather than later.
New Haven, Hartford, Boston, or New York very effectively through cars and trains to get myself around to different functions.
Right, right.
So geographically, it's a really great location to be in, and it's out of the main thoroughfare. Living in New Haven full-time is a lot of commitment.
Sure.
So being able to be 15 minutes away from New Haven is quite advantageous to me.
Right, absolutely. Right. So you're going to soon we'll be developing Maverick 5 and 6, and 7 and 8, and you'll be expanding into different markets, like a myriad of soil sampling and
yes.
Potentially going into contaminated areas and figuring out what may be good, may be bad. Boy, this is remarkable. What advice would you have to other young, or whatever, doesn't have to be young, entrepreneurs? What advice would you have as far as getting something from the concept stage to this stage? And I mean, look, in a second or two, right? Because you already mentioned that you really have to know your demographic. That's like probably the most crucial thing. Correct.
You
And
have
what their
to-
desires are, their needs are, and what you would have to do to accommodate your target demographic.
You have to find your target demographic, and then you have to research your target demographic. You have to do what's called getting out of the building and going and talking to them. Very wild concept. You have to go talk to a significant number of people in your target market to understand if they are actually your target market, which is very important, and there's lots and lots of books on that. And the other thing that I would say to people that are looking to, get into entrepreneurship, start their own business, go explore, go flip over rocks, go meet new people, go find new things.
Do a lot of listening.
Yes, do a lot of listening. But by meeting people like the Economic Development Department in North Brantford, I then got in touch with Canton Racing Products, and that really helped open the doors. By being in that high school robotics program in Guilford, that got me to my sheet metal vendor in Old Saybrook. So by going out and learning about new programs and learning about new things, I then found the right people I needed to be working with. And there's a lot of just needing to go out and explore to understand the world enough to be able to run a business successfully. I mean, it's really hard to run a business in a box.
Right, sure.
I'm sure some people have tried during COVID and it's gone
Right.
okay.
Well, we haven't had much of a choice, but it's not easy though.
But
what you're saying.
Yeah, there's a lot of just go out and explore. And this is what I tell freshmen. They're like, how do I become an entrepreneur? And I say, you need to go intern at a tiny company, you need to go intern at a giant company, and then go find out which one you like. Because
And find out what your passion is.
Yes.
Because this is a combination of all your passions rolled up into, this,
Yes. This is a combination of finding out I like working at a small company. This is a combination of finding out I like working with automation cells. This is a combination of finding out I really like robotics. This is a combination that I found out I really like off-road vehicles.
And you don't have to run yourself into a Jersey barrier to prove anything anymore.
This is true.
So
There's no more jumping off Jersey barriers.
Right, there you go.
But that part was a little bit of fun.
Okay, good for you, not me. Okay, well, this is, I wish you all the best.
Thank you.
Thank you for doing this. And so I was just going to mention something real briefly is, I am one of the people of our Economic Development Commission in North Brantford. And we're going to start doing some vignettes that will be in conjunction with Tuduka TV. And eventually we'll go on our town website. It's a pilot program, I'll say. But please, if you have a business that you would like us to come in and introduce your business to the world of North Brantford and beyond, please give me an email at danarminnb@gmail.com or contact Roger Solway at the town of North Brantford Town Hall at 484-6000. And we can put you on a list and we'll come in and introduce you to everybody and hopefully promote your business. And so people like Emily will know what you do, and that'll be great growth for us, hopefully. We'll see. So thank you for joining me, Emily.
You're welcome.
And thank you everybody for joining us for another episode of I Want to Know. We'll see you soon.